for example, I can get rid of x easily here, right?
Multiply by 2.
So, no.
No?
How do I get rid of x here?
You multiply. Oh.
You just subtract, but
Right.
wouldn't that be easier?
So then I do,
But then you just subtract the next from the other equation.
right, so I do row 1, and I subtract row 2, and I replace it with this row. Let's replace it with that row. Row 2. You see how that works?
Nope.
I do.
I'm taking row 1, and I'm subtracting row 2, right? And then my answer, I'm going to replace it with row 2.
Oh,
You're gonna
okay.
replace it with row 2.
Because then, watch, I do
But you're not touching row 3
x
yet.
plus, no,
Okay.
3 plus 2z, and then x plus y minus 2z, sorry, equals 5 equals 7, and I'm going to subtract it, right? So x plus 3y plus 2z equals
2y.
So I subtract, this becomes 0, this cancels out. I end up with 3 minus 1, which is
2.
and then 2 minus negative 2,
4.
4z equals 5 minus 7,
Negative 2.
right? So then what I'm doing here,
Row 2 is that?
is then I need to get rid of, another x. So which one can I do?
Why don't you multiply the second one by 2 and then subtract the second and third row?
Okay. So this is the same as elimination, it's just each step is explained right here, right? The next one I'm going to do here, I'm going to take
Row 2.
row 2
And multiply by 2.
and multiply it by 2,
And then
Don't
subtract
use
from row
the-
3, or row 3 subtracted
which
from
would
row 2.
equal what? 2x plus 2y minus 4z equals 14, right? Yes? And then, so now this becomes row 2, so I take this, and I do 2 row 2, and I subtract row 3.
Or all the way around.
So it's elimination, but we have to
Why?
explain every single step.
Or that
No.
one works too, I guess.
Right? So I take 2 row 2, which is this, 2 times row 2, 2x plus 2y minus 4z equals 14, and I'm subtracting what?
2x plus 2y plus 3z
Can you not
equals
combine
3.
that second and third step? Or 2 row 2 minus row 3? Or do you have to make that separate?
Which one?
Like, could you do the
Yes,
2?
I can combine it.
Okay.
You're right,
So
yeah.
it's not a big
I
deal.
could have done, yeah, I could have easily combined it for this. I just wanted to let you know how I got 2 row 2.
Can you
Okay.
put the minus in parentheses so it's less confusing?
Wait. What?
Because it's not part of the equation I'm subtracting. So parentheses, what are you confused at?
Plus 2. Okay, that's 2 row 2. Okay. Wait, what did you do with the first thing that we?
This?
No, with the
This.
first. Yeah, where?
I got rid of x, so I'm going to get rid of x again.
Oh, and okay.
My goal is to get that triangle shape, right?
Okay.
So, in this
Right
one,
here in our book.
so in this
Oh.
one I have,
That's strange.
this cancels out, I end up with this cancels out. Negative 4 minus 3 is
Negative 7.
7z equals 14 minus 3, which is
11.
11. Z, we solve here, we do negative 7, negative 7. We have z equals, what's 11 divided by negative 7?
11 sevenths.
What is that decimal?
It's 1.6 or 57 or however.
1.6. So here we have, it doesn't matter which 3 of these I choose. Okay, so I'm going to do the first one. X plus 3y plus 2z equals 5. Then 2y plus 4z equals negative 2. And then z equals negative 1.6.
And then you sub in
And that's our
z
triangle.
and you find y,
So-
and then you have z and
Right.
y, and you plug those in the other one
Yes.
to find x.
What's the first equation relevant for then?
Because I'm going to have to put this in to get y for here. and then I'm gonna have to put YZ in to get X.
Oh, okay.
But I can choose any of these three, right? Any of them, it doesn't matter which ones, because they all should be the same value. You with me? So then I would, in order to do this, I would do 2y plus 4 times 1 point, what is it? 6 equals negative 2. 4 times 1.6 is what?
6.4.
I got this, hold up.
It's all right.
4 times 1.
No.
6.
Oh, yeah, it is.
2, 4, 6 point. Oh yeah, yeah,
6.4.
6.4. My bad, my bad.
And then
Subtract.
Subtracted.
2y equals negative 8.4, and then
4.2. Negative 4.2.
y equals negative 4.2. And then, sorry, I'm going to put it here on there. And then finally, x,
Wait, how did you do this? The first one?
this one?
Yeah.
Oh, this one?
No, the black one.
The black one.
That's the original equation.
Oh, the result. Oh, okay.
It's P. Z is negative 1.6.
Oh, sorry, yes. So then this would be minus,
This is
add,
positive.
add 4.4, 2.2. Thank you, Nico.
Wait, that's one problem.
Yes. Okay.
Wait, that's positive 2.2 then, right?
No.
Wait, what?
Yes.
Yeah.
Yes. Okay, thank you. So x would then be x plus 3 times 2.2 plus 2 times, what's my z? Negative 1.6 equals 5. So 3 times 2.2
6.6.
plus negative 1.6 times 2.
Negative 3.2.
And then 6.6 minus 3.2 is minus 3.4 equals, no, positive 3.4. Minus 3.4 on both sides, I end up with x equals
1.
26.
So my final answer
Is.
I see.
is x comma y comma z. It's always in order of the alphabet. 1.6 comma 2.2 comma negative 1.6.
So, this is like the same thing we learned in Algebra 2, except we're doing this whole pyramid thing.
Right, but this is
Triangle.
for you using elimination, and then when we go over there, we're going to start using augmented matrices.
Okay, and then I have a question with the
Yes.
R1, R2. We're just explaining what we're doing for
To each
each
row.
line,
Mhm.
right, to get each line.
Do
Yeah.
we have to do
But
that?
if,
Yes,
okay,
because you're going to have to be doing it in the matrices, and you'll see why. Because
Oh.
all this work is for a 3x3, right?
Mm-hmm.
So imagine a 4x4 or a 6x6.
yeah.
Us transferring what we're knowing here into an augmented matrix will then allow us to do basically linear programming and do as many, but not as much work, right? Because everything else here, you see, is carried over. We're just editing one part of the equation, but in order to keep our work, we have to rewrite and rewrite.
Yeah.
Whereas the matrix allows us to do all of that with just focusing on the coefficients and not the letters.
So basically what you're
What?
saying is that we could do, if we had the right program, we could just write what we have in those boxes, the blue
And the
boxes.
coefficients,
And the coefficients.
right, and then you
we
write
could
it
do
down with the blue boxes, yes.
Okay, so I don't know, so when we use R1 minus R2 equals R2, then that second row, are we talking about the second row in the triangle or the
This
second row
now
in the original?
replaces our second row.
In our new triangle?
Right,
Oh,
so
okay.
this would have been R2 minus R3 equals row 3.
I
So
see.
then I replace that with row 3.
Mhm.
So row 1 stays the same, row 2 is here, and row 3 is here.
But it's not gonna be as easy as just the second time we try it, we're gonna get the Z. Sometimes we're just gonna have.
Sometimes you're gonna have to do it twice,
Yeah.
right? It replaces row 3, but then you have to do it again to actually replace row 3.
Yeah, that makes sense.
But then you can have two equations to work for row 2 also. So you have options, like you have options here. But you're right, that one we just lucked out that both y and x canceled out. That's not gonna happen every time. A matrix, 5, -5, -5, 35, -1, 2, -3, -5. Okay, so here's the thing. It's actually one of the biggest things I learned when I took this in college.
Yeah.
What's going to happen is the very first few times you're going to be making a lot of little mistakes. It's going to frustrate you.
Yeah.
What you need to do is just keep going, because then you're going to start adjusting to the mistakes you're making, and then by the end of the chapter you should be fully aware. Our goal is to get it into ones on the diagonals, zeros on the left side, then numbers here. This is our answer, C. Okay. What is this called again?
The triangle thing, or the row?
Row echelon form.
What?
Echelon?
What?
Echelon form.
That would be easy
Echelon,
to say.
sorry. It's like German or something.
Okay, that's our goal, to get it there. Once we have it, then we can take this, which is our Z, plug it into here to find our Y, and plug it in here to find plug both of them in to find our X. Okay, domino effect.
Yeah,
And
once
then
we
any
get it like
questions on
that.
what goal we want to get to?
How do we make it so we have all the ones and zeros there first, though?
I know, are we understanding the goal that we're going for?
I understand the goal.
Not yet.
That was the only question.
Not yet. One.
You don't know the goal? Oh no, I'm gonna do still right. He's trying to do it. All right, let's move. My goal is to get -1, 0. You with me?
Mhm.
Okay. I want to get -1 to 0. So if I make this a -5 and add it to this, then 5 plus -5 gets me 0. Yes? In order for me to do that, I have to first make this into a 5. That's what I did. 5 times row 2. And I added it to row 1. Right? And then I replaced it with row 2. You understand where this came from? No. Yes?
Yeah.
Okay. Now, in order for me to do that when we did it yesterday, I first multiplied all of this by 5, and then I added it. I took these as 2 separate steps. Right? But the thing is, we don't have to do that, because what I'm going to do is just do it in my head. Even though it's confusing, it's a lot less matrices to rewrite. You with me?
Yeah.
So this one would be 5 times, so this is telling me what I already did here. So I'm going to rewrite. Lucas, are we all set, kid? Because it's recording, so it picks up everything you're doing. Hurry. So I'm going to rewrite everything that I'm not going to replace.
Yeah.
Right? Because I'm only replacing row 2. Yes?
Yep.
Okay. Then I'm going to do 5. I'm going to apply this to this. Not this one, but this. 5 times 5. 5 times -1.
-5.
It's -5.
Plus 5 is
0.
5 times 2
10.
minus 5.
5.
5 times -3
-15.
minus 5.
-20.
And then 5 times -12
-60
plus 35.
is -25.
You with me?
So we had, it's what we, exactly what we had yesterday, right?
Uh,
Yeah, that's what we had yesterday.
No, yesterday we had two matrices. I first multiplied this all by 5 and then I added it.
But it's, we still had that matrices
Right,
exactly.
right, and we
Okay.
also, yesterday, we didn't, I think I was multiplying rows, but you can't multiply rows together. You can multiply by constants, but you can't multiply rows together.
But yeah, no, I don't think we were
So when I
doing
had this
that.
times this, I couldn't do that.
No.
Right,
Yeah.
so that was a step that we did actually yesterday, okay. So from here, Tanner wanted to divide this so we can get this as 1 by 5. So 1/5 row 1 replaces row 1. So this becomes 1, -1, -1, 7. And then everything else stays the same. Okay, does my steps make sense so far?
Yeah, except why do we do it twice? Why do we now?
I didn't do it the first time, I erased it so that I can emphasize this.
So is this the new way? We're doing,
Oh, sorry. I don't know why I rewrote that.
Why did you just?
Oh.
Because I copied down the wrong part.
Oh, I have a question.
Oh, so now this is our step 2.
Yeah.
Okay, I get it.
If you were to get -1, would that be a problem? Does it have to be
It
positive?
has to be positive. Yeah, that's a good question. It has to be positive. Because that'd be like getting a negative x equals 2.
Okay.
Yeah.
This is OD.
Huh? No, there's still a lot more steps. Are there any questions on this so far? All right, what would our next step be?
So
Adding together row, wait.
Here are our options. I can either try to turn this into 1. I can try to turn this into 0, this into 0, or this into 1.
I want to try to do the 5 into 1. I think that'd be the easiest.
Okay?
So,
Now, before we decide to combine it with any other rows, I can look to see if all those rows are divisible by that number. So I want to turn 5 into 1. I can technically divide everything by
5.
5,
You know, good.
right?
Yep.
So we can do 1/5 row 2 replaces row 2. Everything else stays the same. 0, 1, -5, nope, -4, -5. Okay? Let's try to turn the 3 into a 0. How would I do that?
multiply the whole thing by 0. Just kidding.
Haha, yes. No. Well, you could divide by 3, and then that would be really hard.
I can't divide by 3, that's not
What if you
enough.
multiply? No.
And even if I divide by 3, that would get me a 1.
Divide by -3.
And then you minus.
That's actually.
I have no idea. See, this is where we got yesterday.
Guys, listen,
1 times 3.
guys, we're aiming for a 0, not a 1.
Yeah, but then
1
1
times 3.
plus
We do
-1
R1.
is 0.
Times 3.
What?
I was talking about if you subtracted the row 1 and row 3 and you made it a 1, -1.
You subtracted row 1 and row 3.
wait, what are we trying to do?
Well, because if you made the 3 and
Trying to turn
-1,
3 into
it would
0.
make it 0.
And we're trying to
Yes, but then
turn
we're dealing with all decimals.
-2 into 0.
Yeah,
And 7 into 0.
So we're not aiming for that.
I can multiply the top row by 3.
Okay, exactly what Nico
We
said.
want the
Oh.
So 3 times R1, and actually let's do -3 times R1 plus R3, and it replaces R3.
Wait,
Yeah.
but then we
then
worked
we're-
so hard to get.
Yeah, we changed the 1. Then we're not gonna have the 1 anymore up top.
No,
The
this is
bottom.
what I'm telling you, is that we're not doing these separately, we're doing it the same, and we're only replacing row 3,
Oh.
right?
I
So then we
understand
do
now. That's how it
-3.
makes sense. Okay, okay.
So we do -3 times 1, which is -3 plus 3, which is 0. The only thing I'm replacing is that third row.
Everything else stays the same. That makes sense. Okay.
What are you confused about, Emma?
So we don't even like technically touch the top row.
No, that's what I'm telling you from what we did yesterday. You do it in your head so you don't actually replace the row so you don't mess up that 1.